Yes, welcome back to the session. In this video, I'm going to discuss about Coulomb's law. Okay, so look at the Coulomb's law statement. Coulomb's law states that there is a electrostatic force between 2 point charges separated by some distance, which is directly proportional to the product of the two magnitude of the two charges and inversely proportional to the square of the distance between them. Okay, so look at the diagram here. We have two charges, q1 and q2. Okay, so basically the q1 also I have taken positive and q2 also have taken positive. As we know that positive charges always repel each other. Okay, and in second case, that means the second diagram, the q1 is a positive and q2 is negative. So as we know that opposite charges always attract each other. Okay, so whatever it may be, that these two charges which are separated by a distance r. Okay, so whenever two charges are separated by a distance r, either these two charges will attract each other or repel each other with some force. Am I right? So that force is directly proportional to product of two charges. So what is the meaning? When the magnitude of these two charges increases, then automatically force of attraction or repulsion also increased. Okay, now whenever distance, what is the distance here, r, right? Suppose if distance increases, then force of attraction will decrease. That means we can write it as f is inversely proportional to square of the distance. Okay, now I'm going to combine these two equations. Let's see, f is proportional to q1 q2 by r square. Okay, now if we remove this proportional, we can write it as some constant k into q1 q2 by r square, where k is nothing but 1 by 4 pi epsilon naught into q1 q2 by r square. So this is the final expression for Coulomb's law. Okay, so from this expression easily we can calculate 1 by 4 pi epsilon naught value as well as epsilon naught value also. Okay, so look at here. So from this equation I'm going to take 1 by 4 pi epsilon naught left side. Let's see, 1 by 4 pi epsilon naught is equal to f r square by q1 q2. As we know that SI unit of force is Newton, SI unit of distance is meter, so square will be there. That is the reason I mentioned meter square. And also SI unit of charge is Coulomb and other charge also Coulomb, right? So therefore 1 by 4 pi epsilon naught is equal to Newton meter square Coulomb power minus 2. I told you already, this 1 by 4 pi epsilon naught having a specific value, the value is 9 into 10 power 9 Newton meter square Coulomb power minus 2. Okay, so this is the value for 1 by 4 pi epsilon naught. And also I told you already, epsilon naught also having specific value, right? So I'm going to shift the page. Now I'm going to write the Coulomb's law formula again. So F is equal to 1 by 4 pi epsilon naught into q1 q2 by r square, right? So bring this epsilon naught left side. So epsilon naught is equal to, sorry, one second. Yes, so epsilon naught is equal to 1 by 4 pi f into q1 q2 by r square. Okay, so SI unit of 4 pi is 0, but force having a specific unit, that is Newton. So epsilon naught is equal to 1 by Newton into Coulomb by meter square. So therefore epsilon naught is equal to Newton inverse Coulomb square meter power minus 2. So this is the unit for epsilon naught. What is the value of epsilon naught? So epsilon naught value is 8.85 into 10 power minus 12 Newton inverse Coulomb power square meter power minus 2. So I hope you understand. Thank you. Thank you so much.